So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as visual analysis methods. So this is a different topic apart from in the previous lectures we have already discussed many topics like spatial data, non-spatial data, map projections, coordinate systems and other things we have discussed already. Now today we are just going to discuss about visual analysis methods. So using that all the data, how can we analyze the data, how can we manipulate the data, and what are the different errors we come across while using this type of spatial and non-spatial data. So that we are going to discuss in this visual analysis method. Generally we call it as VAM, that is visual analysis methods. So there are two things, VAM and CAM. So VAM is the visual analysis methods and CAM is the computational analysis methods. So today we'll be discussing about visual analysis methods. In the coming lectures we'll be discussing about the computational analysis methods. So let us start with this lecture today. So before we enter to the topic, we just go through the contents. What are the contents we are going to discuss in today's lecture? So we have the spatial analysis, vector data analysis, buffering, overlay, slivers. We generally call it as common errors of overlaying or errors in digitization and feature manipulation. So this all we are going to learn today. So first of all, let us understand what is spatial analysis. So what do you mean by spatial analysis? So if you remember in the previous lectures, we have learned about the spatial and non-spatial information. So spatial is the data which we see around us and the non-spatial information is the data which gives the information about the spatial. Now after inputting this kind of data in GIS, now how can we analyze this data? What type of data can be done for the analysis so that we can come to a conclusion to get a simple or final output of the data whatever we have input in the GIS process. So spatial analysis, it's a distinction, it is between GIS spatial analysis. In the context of mainstream GIS software, the term analysis refers to the manipulation. When we talk about the analysis of spatial data, that is about the manipulation, okay, manipulation or data querying. When you just manipulate the data, you try to append it, you try to dissolve it, or you try to clip or merge, or this all kind of data. If you want to do this all manipulation, that all manipulation comes under the spatial analysis or data querying. Data querying means when we have any kind of data, we try to query it. Whatever data is fed inside the software, we try to query that data. We just put a question there and finally we can get an answer of that data. So once the data is fed in the software, we can just get the answer of the data. So for example, context of spatial analysis, the analysis focuses on the statistical analysis of patterns, underlying processes, or more generally spatial analysis addresses the question. It addresses the question, what could have been the genesis of the observed spatial pattern. So any kind of question, when it is raised to get a proper information, that kind of questions is given to the software. Until unless the data is fed, we are unable to get the output of the data. So once the data is fed in the software, we are able to get the output of the data based on the spatial analysis. So it's like it's a exploratory process whereby we attempt to quantify the observed pattern, explore the processes that may have generated the pattern. So for example, you record a location of each tree. So there are some trees that are all spatial data. So if you record the location of each tree in a well-defined study area, so that will tell you at this point you might be inclined to make inferences about the observed pattern. So what can we do is, are the trees clustered or dispersed? We just do a query. When we feed this information to the software, we just do this query that are these trees are clustered or dispersed. So is the tree density constant across the study area? So these are some questions we can just put in the software when we feed the data, when we go with the spatial analysis. When you have a spatial data and non-spatial data both combined together. So could soil type or slope have led to the observed pattern? So those are the questions that are addressed in the spatial analysis using the quantitative and statistical techniques. Now let us come to this vector data analysis. So vector data, I hope you remember in the previous lectures we have discussed about raster and vector very clearly. So I hope you are clear with the raster and vector. So let us understand what is that vector data analysis, and this let us recap this information. So vector data analysis, whenever data is converted into point, line and polygon. So based on the raster data, the data is converted into point, line and polygon is called as vector data. So what is the raster data? Raster data is in the form of grid format. Okay, raster data is in the form of grid format. So that is the raster data. So it represents in the form of grid, whereas the vector represent in the form of point, line and polygon. So when you go with this vector data analysis, so we are working with this either point, either line, either polygon. Okay, so the accuracy of the analysis results depends on accuracy of these objects in terms of location and shape. So topology can also be the factor of vector data analysis, such as buffering and overlay. So topology is one of the factor when we talk about the vector data analysis. So we are working with a point, line and polygon. So these are the three types of features where we are working with. Now topology is also, it's a factor that can help us to do the analysis, and when you are going to do the buffering and the overlay options, then we are going to do this kind of analysis. So what is buffering and overlay? Let us understand. So buffering means, based on the concept of proximity, buffering creates two areas. So one area that is within the specified distance of the select and the features, and the other area that is beyond. Okay, so one area about the specified distance, the other area is about the features other than that is beyond. So buffering is what? If you have a point, if you have a line, if you have a polygon. So buffering means it creates a surrounding, it creates a buffer zone around the either point, either line, either polygon. When you talk about point, it will create the buffer zone like this. Okay, so this is the buffer zone. So this is the buffer zone which is created around the point. Now if you talk about the line, so this will be the buffer zone which will be created along with the line feature here and here. So this is your main line, right? So this is your main line and this is the buffer which is created around it. So same thing while polygon, so there will be a buffer zone like this. So it will be created around the polygon feature. So this is your buffer zone which is created. So buffer zone can be about kilometers, we can say 5 kilometers buffer. So if you talk about 5 kilometers buffer, so it will create around the polygon. So this is the 5 kilometer buffer. Now for line, if you talk about 10 kilometer buffer, so it will create a zone around the line feature. Same thing, it will create a zone around the point feature. So here is the buffer and here is the buffer. So this can be a 2 kilometer buffer. So depending on the requirement, depending on the queries, when we asked for it, there we can just put a analysis part. We can just put a query like information that we need a 2 kilometer buffer, 10 kilometer buffer. Based on our requirement, we can just go with the buffer. So the area that is within the specified distance is called as buffer zone. Within the specified is called as buffer zone. So within the specified area, like 2 kilometers area, 10 kilometers area, 5 kilometers area, is called as buffer zone, right? So the buffer distance can vary according to the values of given field. So buffering around the line feature is like here we can see here. So there are three types of buffer here now. Buffering with different features. Now you have a point buffer. So if you have a 2 points here, so around this 2 points you have a buffer like this. Okay. So if it is single point, the buffer will be like this. So 3 points you can see. So buffer is around like this. Okay. This is the buffer zone. Okay. So this is your actual feature. And this is the buffer zone around the feature. Same thing, you have a line you can talk about kilometers. So this all zone is a buffer zone. You can see here this spaces around this is called as, this is buffer zone. Same thing for polygon. So if you have an area, so the buffer zone can be created for the vector as well as raster. So now this is like a pixel you can see here. So around this pixel, the zone is created. So these all are buffer zone. Okay. This is the buffer zone around the area. Okay, so like this we can create a buffer zone around the area. So this is called as buffering. Now here you can see buffering with different buffer different distances. So now here you can see a small distance buffer. This is a long distance buffer. So as you create, so this can be 5 kilometer, 5 kilometer here, 5 kilometer here. This is a buffer zone. 5 kilometer buffer zone. Okay, like this you have for this, you have for this, you have for the small area. This is for the small distance, and this is for the large distance. Okay, large distance. Buffer zone, this is for the large distance. Okay, this is how the buffer looks like. So buffer is just creating a zone around the feature. So either it is a point feature, line feature, polygon feature, depending on the requirement. If you want a large buffer, if you want a large distance buffer, we can create. If you want a small distance buffer, we can create. Okay, next comes to overlay. What is overlay? So in the previous lectures also we have learned what is overlay. So overlaying is one layer over the other. So suppose this is one layer and there is one more layer down of this, there is one more layer. Just putting all the layers aligned. Okay, aligned, exactly fixing its location. Okay, called as overlaying. Fixing its location called as overlaying. So overlay operation combines the geometries and attributes of two features layers to create the output. So as I said here, so we have a two features output. So 1, 2, 3. So what it does, it will combine the geometry, and it will give the output. It will give the output. Is called as overlay. Okay. So the geometry of the output represents a geometric intersection of features from the input layers. Each feature on the output contains a combination of attributes from input layers, and this combination differs from its neighbor. Now for example, we have different types of overlay. So feature type and overlay. Now we have overlay operations can be classified by feature type into. Feature type means point, line and polygon are the features. Now we are classifying into three parts. Feature type into point in polygon. So this is one type of overlay. So this is point in polygon. Now you have line in polygon and polygon on polygon. So you have one type, two type, three types. So you have three types of overlay. Now here you can see point in polygon. So the input is a point layer. So this is the point. Okay, 1, 2. This is the point. The dash lines are the illustration only and are not the part of the point layer. So just to show, if you want to put this point in the polygon, so what you are going to do? So this is the point, this is the polygon. So once you plus polygon, point plus polygon, the output layer will be point and polygon. Okay, point and polygon. So this is the output layer which will combine these two and it will give you the output. Okay, so the output is also point layers have the attribute data from the polygon layers. Now you have line and polygon overlay. So the input line, the dash lines are the illustration. Now this is the input line. One is the input line and this is your input line which we are going to put in the polygon. So this is also input 5, input 2. So if you combine this input 1 and 2, the final, this is the output you are going to get, output. So output is along with the, you have a point plus you have polygon. So this type of overlay can be done. Point plus polygon is called as line in polygon. Line plus polygon. This is line plus polygon. So it is called as is equal to line plus polygon is line in polygon. Okay, so but the output differs from the input in two aspects. The line is broken into two segments, and the line segments have attribute data from the polygon layer. Now you have polygon on polygon. Now you're talking about polygon on polygon. So you can see here we have one polygon, two polygon. So this is polygon 1, this is polygon 2. Now here you have polygon 1, this is polygon 2. Now if you combine these two, 1, 2, AB. So what you are going to get? The final, this is the output. So what is the output? 1A, it has combined here. Now 2A, 1B, 2B. So it has combined into 4. 1, 2, 3, 4. So this is your output. So the output combines the geometry and the attribute data from two layers into single polygon layer. Okay. Now slivers. So what are slivers? So these were the, we can say here overlay and buffer you came to know. Now there is a problem in the overlaying. So when you talk about overlaying, so there is a common error which causes called as slivers. Okay, slivers, common error of overlaying. So a common error from overlaying polygon layers is slivers. Very small polygons along correlated the shade boundary lines in the input layer. To remove slivers, ArcGIS uses the cluster tolerance, which forces the lines to be snapped together and they fall within the specified distance. So what is slivers basically? See, here is the example of sliver. So I'll show you, I'll draw and show. Suppose this is our polygon. Okay. Let us say this is our polygon. And I tried to overlay the another polygon over it. Okay. So it has to snap it here, right? The other layer has to snap on this line. But instead of snapping, what happens? It falls here. Like this it falls. Okay. Like this. So what happens? This is the error, this is the error, this is the error, all the errors you can see here. So it is not exactly fitting to this line. Okay, so you can see here, this is one line, this is one line in red, right? Now if I just change this color of this, so this is one line. Now there is one more line here which has overlaid. So this line has to snap it exactly. Okay, it has to merge through the previous line. So what is happening? Instead of merging, what is happening? Instead of merging, it is just this many errors you can see. Here is the error, here is the error, here is the error. So these are all errors. These are the errors. This should not be there. This should not be there. It has to merge. Like this is a single line, no? Single line. So this two should also, this two lines should be common. Two lines should be common. Okay. Should be common. So there should not be any errors while snapping it. So this line has to snap exactly to the other line. Just it has to merge to the other line. Now same thing you can see here. This is one polygon. So this line and this line has to merge. Exactly, it has to snap. It has to snap. So this is the error here again. So it is looking like it's not snapping. So here is the error. So this error has to be removed. So how it will be removed? When this point, this vertex will be snapped to this line. This vertex will be snapped to this line. So this is how, this is also one error. Here is also one error. Here is also one error. So these are all errors. These are all errors. It has to snap exactly to the line. Okay. So the top boundary has a series of slivers. These slivers are formed between the coastlines from the input layer in the overlay. So when it happens, when we try to overlay two layers. So here is one layer, the other layer 1. This is layer 2. So layer 1, layer 2. So if you try to overlay this to here, so this should fix exactly 1 and 2, 1 plus 2 should fix exactly on this layer. Okay, so this is called as overlaying errors. Now here very clearly you can see sliver error. So this is the boundary. This is the boundary, right? This is the boundary. Okay. Here is a boundary. Now if you try to, like this is the boundary. Now we have just overlaid one more boundary over it. So it has to snap it, right? It has to snap it here. So what is this? This is the error. This is the error. Here is the error. Here is the error. Here is the error. Okay. Now what we are going to do is just we'll select here. We'll just snap it. We'll put a vertex here. I hope you remember what is a vertex. Okay, vertex point. So some points we will put like this. Okay, so these are the vertex we will put to merge it properly. So these points are merged here exactly. So what we do, just we move this line till here. So exactly to snap it on this line. So once you snap this line, once you move this vertex here, you have to move the vertex here. Okay. So once you move the vertex here, it will exactly snap to this line. So the error will be removed. So this is how we can just remove the errors. So this is a very common error when you try to overlay So this type of error is very common, and we have to remove this with the help of the software again. Okay. Now next is errors in digitization. So that was the overlaying error. Whenever you try to overlay, that kind of error will come. But the common error we come across is overshoot and undershoot. So these are the two errors we come across: overshoot and undershoot. So what is overshoot? What is undershoot? Let us discuss here. So overshoot in GIS, overshoot specifically refers to the topological error where a line segment extends beyond its intended endpoint. Okay. So suppose this is your boundary and there is a road from here to here. Okay. So we'll just draw this road with the help of the vertex. Okay, help of the vertex. Now it has to end here, right? It has to end here. So what will happen? We'll just snap the line here. So this much portion is overshoot. So we are just, this much portion is the error. It has just extended the line, called as overshoot. So this often occurs during the digitization process when the endpoint of the line overshoots and intended intersection with another line. Now what are the causes of overshoot in GIS? So causes of overshoot will be manual digitization, data conversion, inaccurate snapping. So what is manual digitization? Manual digitization process. So if you remember what is digitization, just we are converting the raster to vector. Okay, raster to vector. So if we have a raster data, we try to convert, this is grid, we try to convert it into point, line, polygon. Okay, so this is how we convert this data. So manual digitization, when digitizing maps manually, errors can occur if the cursor is moved too far beyond the desired endpoint. So while digitization process, if this is the map, so you have just started digitization. So here one point you started, the other point started, and suddenly the cursor moves and ends here. So this type of error comes under the manual digitization. Data conversion. Converting data between different formats or coordinate system can sometimes result into the overshoot. So when the data is in the different formats, that time the problem occurs. And the inaccurate snapping, if the snapping settings are not appropriately configured. So snapping settings means we have from here to here if you want to snap. So you have to snap from here to here. So this line has to finish here. So you have to enable the snapping option. Okay, snapping option in GIS. Okay, snapping option in GIS. So once you enable the snapping option in GIS, what happens? This type of inaccuracy will not occur. So what will happen? Suppose here is your map. So if you start from here, it will exactly snap here on the endpoint. it will not exceed. So this type of error we can reduce based on this type of causes it happens. Now undershoot. What is undershoot? So that is the opposite of overshoot. So this is the map. So your road is from here to here. Okay, so you have to draw this road. This is starting point and this is the end point. So what happens? What you do? We just start the digitization process like this and we end it here itself. So where is the gap here now? This is the gap. So this gap is the error. Okay. So GIS refers to the topological error where the line segment does not reach its intended connection point, falling short of intersection with another line or boundary. So this is how the undershoot and overshoot looks like. Now undershoot, you can see this gap. Okay, your line is from here to here. So where this is the gap. So this is the error. It has to fix it here, but it has completed here only. Now overshoot, it has to fix it here. It has completed here. So this is called as overshoot. This is called as undershoot. These are the common errors in digitization process. So one more example here. Overshoot. Here the line it is crossing the line. Crossing line is overshoot. And before finishing before line is called as undershoot. Now this is the correct one. So it has to snap here exactly. It is corrected here. This is wrong. This is wrong. Okay. Feature manipulation. Now coming to feature manipulation. So what kind of manipulation we do in the spatial analysis or visual analysis methods we can talk here. We can just learn here. So feature manipulation tools are available in GIS package for managing maps in the database. So these tools include dissolve, clip, append, select, eliminate, update, erase and split. So there are different tools where we can just utilize it for the manipulation of the features. So what is manipulation of the features? We can just try to merge the features. We can try to clip the features, try to erase the features, try to split into 2 parts or 3 parts, or as per the requirement we can just do this all manipulation in the feature manipulation. So what is a feature here? Feature we are talking about vector data. Vector data. Okay. So what is the vector data here? Vector data here is point, line, polygon. Okay. So 3 are the features here, vector data, or else we can call it as the shape files. Okay. Shape files. We use this for the feature manipulation. So these all tools we use it for the dissolve, clip, append, select, eliminate, update, erase, split. So these all options can be done only for the vector data. Okay. So let us see what is dissolve first. So dissolve is like it removes the boundaries of the polygons that have the same attribute value. Now you can observe here 1, 1. So this 2 I want to make it 1. So what we are going to do is we are selecting this one, selecting this one. Okay. Now you see here 3 and 3. So this we are selecting. Even this we are selecting. Right. Now 1 is okay, 2 is okay, 4 is okay. Now after the conversion of dissolve. So what is the result? So this is the output result. This is the output result. So when you merge this two here, when you merge this one, it will come to a single polygon. Now these are the 2 polygons. 2 polygons. Now here it has converted to single polygon. Okay. So this is how the manipulation we can do. If you want to make this 2 polygon to a single polygon, we can just select first polygon, second polygon, and finally we dissolve it. Like that we have the same thing here. 3 you have to select, 3 you have to select, merge it. So what will be the output here? So it will convert into single polygon. Okay. So this is how we do the dissolve in the analysis part. Now you have a clip. Clip in, this is the clip option. Clip in geographic information system refers to the spatial operation that extract the features from one layer based on the spatial extent of the other layer. So clip is essentially is like using the cookie cutter, the clip layer of the cut pieces out of the another layer. So clip is like, suppose this is your boundary. From this boundary, if you want to remove this part, okay, this is your boundary. From this boundary, we are going to remove this part. So what we are going to do, we are going to select this area. We are going to put this as an input. We put this as an input and we run the clip process. So once you run the clip process, what will be the output? So your final output you will get like this. Okay, this is your output. So this is the example here. So this is your input file. Input file. So in input file you can see you have this layer as you have green, blue, white, and you have a 2 points here. Now this is your clip feature. So you want to clip here. This is the clip feature. So you are going to overlay, just overlay on the input file. Just overlay on the input file. So after overlaying on the input file, what is the output you are going to get is this. Okay. So once you overlay exactly like this on this feature, so when you run the process, run the clip process, this is the output you are going to get. Okay, this is the output along with these 2 layers. So this is your output. You have a boundary like this, clip feature boundary. You have this blue color, green color as a point and white color. So wherever this boundary will be overlaid, so that area is totally removed as the output. Now you have an append feature. So append refers to the process combining the multiple datasets of same type of into a single datasets. So this is useful when you have several layers or files that represent the same type of data you want to create in a single comprehensive layer. So what is append here? Now you have an input file, you have 2 layers here. So this is layer 1, this is layer 2. So this is your input file, layer 1 you can see. Okay, layer 2 you can see. This is extended till here. Now finally you run this append process. So what will happen? This 2 layers will convert to single layer. Okay, single layer, and it will take the attributes will be combined. Okay, attributes will be combined together to form this output. So this is your output. Okay. Now selection is the GIS. In selection, GIS involves choosing specific features from a data set based on the creation certain criteria. Okay, certain criteria. So what happens? This process can be performed using various methods depending on the desired criteria for selection. So it is like selecting a feature. So when you have so many features here, you have a features like this. You have a features like this. Okay, you have a features like this. So what we are going to do is just select whichever you want. So if it is selected, if this is selected, so along with the attribute, it will just remove the selection. So for example, here you can see here the selection is highway. Okay, so these all are in selection. So wherever we select, unselect. So once you select this from the spatial data. So once you select, automatically the features will be highlighted. Okay, features will be highlighted. So once the features is highlighted, what happens? You can just remove these portions, or you can just select this features. Okay, and as per our wish, if you want to delete or erase or merge, based on that we can perform the analysis. Okay. Next you have erase. So erase tool is a geoprocessing operation that allows you to remove or erase the features of one spatial dataset from another based on their overlap. So if you want to erase, same example you have, this is the map. So from this map you want to erase some portion. So this is the portion you are going to erase. So what you are going to do is, so this is your input file. So in this input file you have this erase feature. So you are going to put this erase feature over this into input file like this. So this much we are going to erase. So this is the erase feature. We are going to overlay and run erase process. Run the erase process. So once you run the erase process, this data will be erased. So this data is erased now. So this is your output file. Okay. So this is the analysis you can do in GIS while performing the visual analysis methods. Now you have a split option here. So split operation in GIS is used to divide one layer into multiple smaller layers. So splitting is like if you have a line, big line here, so you want to split it into 3 parts. Let us say this is your line, so we will split in 3 parts. Okay, so this is line 1, this is line 2, this is line 3. So what we are going to do is we'll select this line, select the line and run the process. Run the split process. Okay, run the split process. So what will happen? The single line will be transformed to 3 lines. So this is the single line. This is the single line. So now this line will be splitted into 3 parts. So one line, line 1, 2, 3. Okay. So this operation is useful for segmenting data or to focus on the specific regions or categories of analysis and management. Next you have, this is how we can do the split option. So this is your input file. So this is the input file. This is a single polygon. Single polygon. So once you select this polygon and you want to split it into 2 parts, split it into 2 parts. So what you are going to do, select and run the run split operation. Split operation. Okay, run the split operation. So what will happen? It will convert to polygon 1 and 2. So this is the selected one. So once you select this, it will select. So this will convert to 2 polygons. Okay. So these are the all feature manipulations we can do in GIS. So when you talk about the visual analysis methods, so visual analysis methods is about the spatial analysis. How can we do the analysis visually? What type of data we can just use it? So that the data which we are going to input in GIS, that data can be manipulated with the help of these are all operations we can do. Okay, split if you want to do split, if you want to merge, if you want to clip, or if you want to append, that all operations we can do. And overlay operations we can do in the visual analysis methods. Overlay and buffering we can do. So while doing overlay, we come across the errors like buffer slivers. Slivers are the errors. And while slivers, while digitization, we come across the errors called as overshoot and undershoot. So undershoot and overshoot has to be manipulated with the help of this visual analysis methods. So these are all methods where we can just use this vector data, and this vector data by point, line, polygon, the feature type which we are using based on our requirement, we can just use the data for the manipulation purpose. Okay, so these are the references you can just go through. MNG Ready book, as usual, you can just refer for all the topics, and these are some links where you can just go through the more content if you want to know about it, then you can learn it. So I hope you understood about the visual analysis methods. Generally we call it as VAM. So visual analysis methods, different kinds of spatial analysis we can do in this, like overlaying, buffering, splitting, merging, different kinds of errors, whatever errors while doing the manipulation we come across, that we can just learn in this topic. Okay, so that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.